Well, so good afternoon, everyone, once again. Thanks for coming for this session. My name is Puneet Agrawal, and I'm a solutions architect at AWS. And today, I'm joined by Christian Egler from Verizon Labs. Christian is director of VR and AR at Verizon Labs, and Vinay Polavarupu, who is the lead architect at Verizon Lab. So the session is about powering next-generation virtual reality with Verizon. And the purpose of this session is to really give you an idea of how some of our sophisticated customers are using AWS to provide virtual reality and augmented reality experience to their end customers. In a very short period of time, Verizon has developed a really interesting platform to stream VR and AR experiences in real time to their end customers. And it has many unique aspects to it. So we thought that it'll be great for our audience to know how you can develop such workloads on AWS, leveraging Verizon's experience. So Verizon's used a bunch of AWS services in order to build this platform. They used S3, CloudFront, they used ELBs, VPCs, all the standard services. They used Amazon Aurora for their database. So they used many AWS services. But what they heavily used for video processing was AWS GPU instances. So before handing it over to them, I just wanted to give you an idea of your GPU choices in AWS. And I think my slides are already outdated after the announcements today morning. Some really interesting announcements around GPUs for EC2, very interesting stuff, and with F1 instances. So you won't see that on these slides. I didn't know that we were announcing those today. But of course, those are the new options that you have. So AWS GPU instances. Well, you have multiple instance options in AWS as a customer. General purpose instances for everyday workloads. You have compute optimized instances for CPU bound workloads, memory optimized instances for your databases, storage optimized instances for big data workloads or any workloads that are storage bound. And then you also have micro instances, right? T1 instances, T2 instances. You can run your dev and test workloads on those instances and your websites. For GPU instances, we launched our first GPU instance family, CG1, in 2010. So we have done this for a while now, almost 6 years. And in 2013, I believe, we launched our G2 instance family. So our customers across the board use G2 instances for many years for various use cases. So I'll talk about those use cases as well. And then the latest generation of GPU instances is P2 family that got launched about a month ago. So P2 is a general purpose GPU instance family. So what that really means is you can leverage P2 instances for a variety of workloads, right? It doesn't have to be just graphics processing or video processing. You can use P2 instances for many different things. So our largest P2 box has about 16 NVIDIA Tesla K80 GPU cards. And you get that on a single instance, right? So that's really difficult to do to get this much GPU power in a single instance. So the 16X XLarge provides you with that. You also get 192 gig of GPU memory, and that's different from the regular RAM that you get on the instance. And you also get 40,000 CUDA cores on 16X extra large instance. For single precision floating point performance, you get about 70 teraflops. And that's critical for video processing workloads and other media processing use cases. But for scientific simulations and calculations, fluid dynamics, you really need double precision floating point performance. And you get that with P2 instances, about 23 teraflops of double precision floating point performance. And the double precision floating point performance, this was something that wasn't available on the G2 series. So this is a new addition to the P2 series. In terms of different instance sizes, the size options, you have option of P2 extra large, P2 8 extra large, that comes with 8 GPUs, and P2 16 extra large, that comes with 16 GPUs. With 8 extra large and 16 extra large, you also get GPU Direct which lets two GPUs access each other's memory pretty quickly. So you have those features. And as you probably heard in the keynote as well, we see a lot of customers using CPUs and GPUs at the same time, right? So they would use CPUs for majority of their workload, but for some compute-intensive part, they'll leverage GPUs. So if you look at the CPU and memory configuration for these servers, that's pretty beefy, right? So with 16 extra large, you can get up to 64 virtual CPUs and about 768 gig of RAM. If you use these instances in a placement group, you can get about 20 gigabits per second speed. So if you're not already using GPUs for your workloads, a natural question in your mind could be, well, why should I use GPUs, right? Why should I worry about GPUs? So the way GPUs work is they are really good at performing certain type of functions, certain types of calculations. CPUs are still great for our everyday computation needs because CPUs are kind of a Swiss Army knife, right? They can do a lot of different things in parallel and do it really well. While GPUs are really good at some specific workloads, right? So with each GPU, you get about hundreds or thousands of processing cores, and that enables parallel processing at a very large scale for your workloads. So with that, you get higher throughput, you get lower latencies for your computation. It lowers the overall cost of your computation needs because now you don't have to buy a really big CPU box, and you can lower down your average utilization on CPUs, so you save some money there. And of course, it's efficient with power. So GPUs are everywhere. GPUs are nothing new, right? They've been around for a few years, and we see many developers and system integrators use GPUs all over the industry. And the new trend that we are seeing is a lot of customers are using GPUs and CPUs in hybrid mode. So what they would do is they would go through their application, and they will identify block of codes or hotspots that can really use some GPU hardware acceleration, right? So they'll identify that code block. They will offload that processing on GPUs. And in many cases, they improve the performance of their applications dramatically by doing that. So they improve the performance. They lower down their average CPU utilization on the CPU side. So they get lower cost and much higher performance for their applications. A lot of system integrators are doing this. If you're looking to improve performance of your applications, and if you have GPU use cases, definitely look into that. And with the GPUs for EC2, I think this paradigm is going to be even more popular. So some of the common use cases for GPUs. Machine learning is a very common use case where GPUs are utilized heavily. Engineering simulations in manufacturing industry. A lot of our financial services customers use GPUs for financial simulations and forecasting. Virtual reality, Verizon is a great example for that. They'll talk about that. Accelerated databases, video rendering, transcoding, and many more use cases. But with these use cases, you sort of get an idea of what GPUs are really good at. So to give you an example of machine learning, one of our customers, Samsung, they have a Russian facility that specifically develops machine learning algorithms for their electronics division. So Samsung was using GPUs in their own data centers before, but when they adopted AWS GPUs, they of course got access to hundreds of GPU servers on demand, right? So they didn't have to invest in their infrastructure. They could spin up multiple GPU instances from AWS on demand. And I think the most important thing that happened for them was they reduced their machine learning algorithm development time by 50%. And that was really the big win for them. Because instead of investing money in buying GPU hardware and not able to scale it, they chose to use AWS GPU instances. For the next example, the example on virtual reality, I would like to hand it over to Christian, who will talk about how Verizon developed their platform on AWS.
Thanks, Puneet. So Let's get started here. Let's describe myself a little bit. So I'm the director of virtual and augmented reality products at Verizon. When Verizon thinks about things, they tend to think about things like platforms, sometimes even more than they do individual products and services. So, my job is to look at, the different parts of the business where we can apply virtual and augmented reality technology. And then with me, who's going to speak afterwards and really dive into a lot of technical detail, is Vinay Palavarapu, who is our chief architect for computer vision for the environment platform at Verizon Labs. So what we're going to be talking about in this presentation today is some of the challenges that are there now in developing AR and VR technology, as well as how Verizon Labs has used the GPU infrastructure on AWS to overcome some of these key technical challenges. In addition, we're going to talk about what our initial architecture was when we started working on this, and then how we leveraged AWS to come up with an improved architecture. And then finally, I'm going to show you a few demos of how we've used our platform to enable both an AR and VR experience in the real world. So at a high level, Verizon does a lot of things. As you know, we are primarily known for our wireless and wireline communications network. We're known for our large 4G LTE network. We're known for our Fios fiber network. In addition to serving consumers, we have a large enterprise business that targets both the public safety and enterprise markets in several sectors, such as retail and utility. We have a video streaming business called Verizon Digital Media Services that delivers digital media on a global scale, paired with a CDN network called Edgecast. And then Verizon has multiple other platforms that focus on different things like security, Internet of Things, and advertising. And then, not only do we have those, but then we recently, around 2014, acquired AOL, and then paired our service and communication platforms with a lot of digital media technologies and content. And some of those are very probably well known to people in the room. We have digital media properties, things that you read about VR and AR all the time on, such as TechCrunch and Engadget. We have a lot to talk about when it comes to automobiles with Autoblog. And then when it comes to general news, we have Huffington Post, as well as our Go90 digital media video network. And then we have additional other properties that talk about and cover in digital media all sorts of genres like lifestyles, entertainment, and other types of news. So Verizon is positioned to enable all of these different technologies with AR and VR because all these things together power dozens of different types of devices and services with an evolved network. We help our business and our customers innovate and do many, many things. And Verizon as a whole, with us and AOL, we serve as the bridge between advertising and content and streaming of all sorts of types of content. And retail, our retail presence is huge in terms of getting out products to consumers. And then our actual big core asset, our network, which today is the largest 4G LTE network in the US. And now, as many people may also know in this room, we're the first to jump into the arena with 5G. And so we feel like that, these assets individually or all together as an aggregate serve as a super awesome ecosystem for AR, VR creation, hosting, and distribution, and ultimately enjoyment and delight by our customers. And so the vision. So, Verizon is, we're familiar with selling smartphones, and we generally know that the smartphone market is maturing. And a lot of us are saying, what comes next after smartphones? We're all thinking about what comes next. We're thinking about different types of devices, frameworks. We had smartwatches come out a few years ago. We're now starting to percolate the ecosphere with different types of headsets. And we believe that if headsets do take hold, the type of technologies that will enable them are major advances in augmented and virtual reality. And so that's great, but there are some significant challenges that have to be addressed first before this technology becomes even more mainstream. And a lot of it has to focus on new advances in silicon and some of those challenges around the network, which I'm going to go ahead and talk a little bit more about today. So with that in mind, to create an ecosystem where headsets are dominant, to be able to deliver richer, more interactive types of experiences, what type of challenges did Verizon Labs have to tackle? So we basically put our heads together And then we came up with a platform that would enable the different sectors of our businesses, the different sectors of customers that we have, and we call that platform Environment. And what essentially Environment is, it's not only just a platform for delivering new types of content and next generation formats, but it's also about delivering reality itself. And when we think about how we create these different realities, whether it's consumed in both VR and AR, we're also looking at how do we enable those, how do we create those with easy-to-use tools. And then to make it richer and interactive and make it a service just like people watch 2D digital content today, we have to make sure that we can then live stream those AR and VR experiences. And since there are interactive experiences, we have to make them interactive with multi-user support and bring people together so that they can participate in those experiences. And then ultimately, we want to create experiences where there can be digital advertising that's monetizable. We can create rich interactive content that gives and allows people to interact with the things that they want to buy in a way that's never been known before, and provide those on the smartphone and headset. So Environment as a whole accommodates all different types of captures and media. So we've worked with a lot of different camera rigs out there to be able to ingest 360 video content, for instance. We have machine learning where when a new camera rig becomes available, we actually, by uploading more content, we learn, and it gets better and better over time. We have then the ability to then live stream and live stitch that content. So, and then be able to offer rich interactive tools so that while you're live streaming that content, you can put in things, you can overlay things, you can create 3D objects, you can make it more rich and interactive. And in addition to just doing, making a more traditional media format more rich and interactive, we're interested in building tools to essentially allow you to create worlds that then can be experienced in some kind of augmented or virtual reality experience. Whether it's a small experience or a very large experience like an entire environment, we want to enable that with our tools. And then we also want to then leverage the other parts of our business, and we want to be able to bring in digital advertising in a way that is unintrusive, interactive, and fun for people to use, which, as you know, that would be a major win for all of us, right? And then being able to then view that AR and VR content anywhere. So for us, we're more interested in being able to enable the entire ecosphere. So whether you want to experience your content on Gear VR, you want to experience it on the Vive, or you want to experience it on Daydream, we want to help enable that so that everyone can use the Environment platform to both create and then deliver and then experience that content. And then ultimately, whether it's a combination of just super smart algorithms or network routing, delivering it over the top, we can do that. Or, I can also then go into like things that we want to do on the network so that we can deliver these types of these rich experiences both fast and seamlessly. So with that, I'm going to now go into a little bit of the technical pieces behind Environment, and I'm going to pass it off to Vinay.
Thank you. Thank you, Christian. Yeah, I get to do the boring part, technology side. More of architecture, deep dive into how we leverage the GPUs that Puneet touched on, and do all that, again, boring stuff. So why we chose to build our Environment VR AR platform on AWS. So when we started a year ago to develop this platform for VR AR experience, we are in a startup mode. We basically started with nothing. We have a task of building a new team, finding a right infrastructure as service model, because we don't want to spend on any capital expenses as far as the hardware is concerned, and also don't want to solve the problems related to the application layer, database layer, be network or CDN, where in those domains the problems are already solved. We just want to pick and choose the right solution and focus on VR AR space. So those were the driving factors, and AWS was a clear winner. So wherein AWS provides different options for us at each layers of at each level of application stack, be it at the network, like highly available architecture, or security layer, application layer, or the database layer. So as I deep dive into the architecture, I'll show you all what technologies that AWS provided we leveraged. Again, the flexibility, like by having this option of choosing the right solution, we have the flexibility whether we can go to our own implementation or pick from many open source solutions or the solutions provided by AWS. So what we built on AWS platform, we basically built the end-to-end AR, VR content creation, hosting, and delivery platform. We used enterprise design model of microservices architecture, where each microservice can have its own defined interfaces and interact with other microservices through REST APIs and interact with the backend through message queuing. It's a very loosely coupled architecture model where we can change each microservice based on the business requirement very easily without affecting the integration with other microservices. So using the microservices model, we built the authoring ingest service, which lets our content users and partners ingest their content into our platform quite seamlessly, quite easily. And the media library service, which lets our player pull the content that's ingested by our content partners and provide the VR experience to the end users. The ad service is quite critical for our ad partners to push their ads into our VR platform, which will bridge the monetary requirements that are pretty essential for our content partners to serve the required ads to the end users. That brings to the backend system of real-time stitching and encoding, which is where we wanted to focus on to create the right VR experience. So I'll do a lot of deep dive into this part in the slides that follow. So the real-time stitching and encoding delivers adaptive streaming capability to our end users. If the end users are requesting the content from Android device, it dynamically produces the MPEG dash from MP4. And if it is being requested from iPhone, it will dynamically produce HLS content. So, and we also developed our own VR player for Android and iOS, which uses the 360 spherical projection for immersive experience. So some of you here might not be aware of what stitching is about. So stitching is the very fundamental part of how our partners create VR content. So there are many rigs in the market, VR rigs, be it GoPro, Facebook, Google. Verizon has its own rig. So the rig has the capability to mount anywhere from 6 to 16 cameras, be it a wide-angle camera, be it a dome camera. So using those cameras, you can capture the footage on the field where the event is taking place, be it a sporting event, be it a convention just like this. So you can capture the footage, many sets of footage, and then bring it to your lab and upload into our environment ecosystem that I was talking about. So our environment ecosystem creates the stitched output, which gives the right VR experience to our end users. So this is some of the footage that our customers captured. It's just the image, JPEG images that I put in here. So this is a 7-camera. This is captured using a 7-camera rig, GoPro rig. And this is the stitched output that we produced using our automated stitching pipeline on our VR AR platform. Thought it's supposed to play here. Anyway. So this is the overview. Go back. Yeah. Yeah. That's fine. Yeah, that's fine. So this is, if you play this in a 360 video player with your headsets on, you will have an immersive VR experience. So we created this using our VR platform at near real-time speed. So I'll go through those details on how we created the output at near real-time speed. So this is our architecture overview, so which depicts the microservices architecture model that I was talking about. The users, the ingest users, the players, and the ads engine, the analytics engine, they all interact with our microservices backend through the elastic load balancing layer, and on the services layer we have the EC2 machines distributed across multiple availability zones, and with the RDS Aurora backend, the master being in one availability zone and the slave in the other availability zone. And the data sharing happens on S3 layer. The content that comes in gets ingested into S3, and the encoding backend engine picks it up as the content comes in, and provides real-time encoding experience. The stitching engine and encoding engine interacts with the service layer through messaging, picks up the messages, and starts the stitching and encoding part. So this is all during the initial iteration. This is all implemented using CPUs, on CPUs. So what we observed after our first iteration is we are not meeting the base requirement of delivering low latency, high resolution content for a very good VR, AR experience to the end user. So we have a technological dependency. We rely on the computational power of hardware as well as the latency of the network to deliver the low latency experience to the end user. As per the study conducted by Ericsson in 2014, they predict that the mobile data traffic growth is projected to grow exponentially and grow tenfold from 2013 to 2019. And VR is going to contribute a lot towards that growth. So on the computational side, GPU computational power is taking off, as Puneet was pointing out. Most latest generation of GPUs are coming into marketplace, so they're going to bridge the gap to decrease those latencies. So we found a perfect alliance with Amazon, where we can easily provision these GPUs, utilizing the CUDA framework that NVIDIA provides to enhance our stitching algorithms and encoding algorithms to produce near real-time experience to our end users. So using the GPU class of EC2 instances, we are able to achieve the near real-time stitching capabilities for stitching and encoding capabilities together. And I'm going to discuss a little bit more into that. So let's do the live stitching. So when you talk about live stitching, I showed you how the live stitching works from input to the output. So there are many parts of live stitching. For those who are familiar with the stitching, you decode the input, you kind of undistort the input, and then warp it to the projection that you want to do, like a spherical projection, and then blend across seams, like fix the seams and blend across the seams, and then adjust the exposure. So that gives a uniformed VR experience to the end user without showing any stitching lines, without showing any exposure differences. So we developed these algorithms on GPUs. We rewrote all our algorithms that we wrote on CPU using CUDA on GPUs, so which increased the speed 10x. So we were doing about 10 frames per second before. So after we implemented those algorithms on GPU, the speed went to about 110 frames per second. So which is more than sufficient for the real-time experience. So this graph depicts the frame rate that we achieved for stitching on different classes of hardware. So on M4 16x large, the general purpose CPU class, we achieved about 10 frames per second, and on G2 8x large, we achieved about 55 frames per second, and on P2 16x large, using peer-to-peer computing capabilities, peer-to-peer data transfer, we achieved about 110 frames per second. So that brings to encoding. So encoding has many functions inherently in it. So it has entropy coding, it has motion detection, and it has block estimation, it has a color correction and things of that nature. Some of it is computationally intensive and some of it is sequential. So we found out that it doesn't do similar, it doesn't give us a similar output if we do that on GPUs. So we decided to go with a hybrid model where we do some of it on, we do decoding and video rendering on GPU, which is for stitching, and then the encoding on CPUs. And that gives us an aggregate speed of about 40 frames per second, which is good for real-time experience of most of the content, but still some content producers send us 60 frames per second, 100 frames per second as well. So we can't do real-time for those. So there is still work to be done to achieve real-time speeds for high frame rate content. So how do we plan to achieve it? There is work in progress to split the CPU functions across GPU and CPU. I think there are entropy coding and motion detection can be shifted to GPUs, and then have the other functions still continue on CPU. And then I feel we can achieve the real-time speed using that model. Our peers, some of the peers that we interact with, they say they're able to do real-time encoding on GPUs. So this is the revamped architecture after we incorporated our GPUs and CPUs into the overall architecture, right? So the decoding and stitching is happening on GPUs, and live stitching, encoding is happening on CPUs in this model. So overall, to summarize the benefits of new architecture, you need to leverage the strengths of GPUs and CPUs as per their capabilities. So as I was explaining before, 2D and 3D rendering fits the bill perfectly for GPUs. Encoding is doing well on CPUs. So with that, I'll turn it back to Christian for some demos. Thank you.
All right. So Vinay just really talked about some of the things that we did to revamp our architecture so that we could start to deliver real-time speeds for 360 content. And so, once we talked about how we revamped environment to be able to do real-time 360 video delivery, as well as looking at ways to deliver new, rich, interactive forms of content, we ultimately, what we want to do with this type of technology is we want to be able to become that platform that streams augmented and virtual reality content to a wide variety of cross-platform devices. We want to be providing our world builder tools so that people can easily create experiences and be able to monetize those with advertising, and then allow them to be able to, and then allow our customers who have those experiences to be able to access detailed analytics. So I'm going to go through and now show a couple of demos around AR and VR, and I hope that they'll play fine because it seems like we're having some problems with the video player. Okay, well, that's good. No problem with this. So this is an example of an AR experience that we built with our AR experience tool. Essentially, this is the November issue of Elle magazine that went live. It was a featured 10 Women in Hollywood issue. And so as you put your iPhone over the experience, what you're actually seeing is a video overlaid on top of the magazine cover actually playing, and a segment about each of these 10 different featured women in the magazine for this month. And so what's really cool about that is not only the fact that it's a very easy to use example of augmented reality technology. Everyone has, a lot of people have iPhones. This experience was embedded inside of the Elle application itself, so it wasn't something that was put into, say, like a Blipper app where you had to download Blipper first. It was already put into a third-party app. Hearst Media was able to easily integrate our environment SDK into their app to be able to both create and then deliver this augmented reality experience. And what we feature is that ability to then be able to have them publish their content and then be able to stream that content to the device in real time, instead of having to like preload all of the assets, which is very common today in a lot of augmented reality experiences. And so, this is just a brief example of like where we can take physical media. So, in the things that we're already thinking about is how we can make, whether it's books or other types of magazines, more rich and interactive, and be able to make each page come alive. Whether it be with featured advertisement page, or whether it's makes editorials more interesting, or even allows authors to write their articles and then be able to put in more rich interactive content. And so when I talked about before with the, quote unquote, what I call the world builder, this is, essentially what I was talking about when I said creating a small VR experience, because it's not creating an entire environment, so to speak, but it's creating a single contained small experience that's strictly related to this magazine cover. And we're very excited about seeing how we can then take this ability to stream content in augmented reality experiences further, both later this year and in the first half of 2017. And this is something that the environment platform was built from the ground up to be able to support. And then, I'm going to pivot a little bit. So we talked about how we can do AR. And, imagine if, so if I leave this here and I say, hey, look, you can do videos, you also project rich 3D models, you can do 360 video on the magazine cover. That's just a single object. But what if I pivoted to talking about virtual reality and then talking about why is it not clicking? All right, talk to about a social VR experience. So this is something that we first actually showed at a NVIDIA GPU conference. It's essentially our Halloween-themed social VR experience. What's very notable in this experience, besides seeing a little social avatar version of myself that people are slapping around, is that it's something where most of the content that you're actually seeing here is actually being streamed. So when you look at the objects itself, those can be streamed, as well as the Night of the Living Dead video. You could watch the entire video inside of this experience from start to finish. And so you can basically move around, you can interact with other characters who are in the car watching the video. And so this uses a teleportation model so that we can deliver this experience for both, say, a Daydream mobile VR headset, as well as experience it in the HTC Vive. So we use teleportation as just a common technique so that it can be supported on both platforms rather easily. And as you move around, you're just basically able to see the different environment. You can see the billboards there, so those are actually real streaming advertisements that can be based on user preference. They can see different things as far as they're concerned. Everybody can see a different digital advertisement. They can see the stuff that they want to. And then you can place in different things, and they can come in and out, so you can see the shambling zombies. If you wanted to have fairies, I suppose you could have them there as well, inside of this experience being streamed into this environment. And so as you move around, the goal is to then be able to create this rich environment. You can watch the video, you can talk to your friends, and most importantly, you don't really have to constantly update new apps to experience this. If you're a content creator and you want to publish all these experiences in your app, you can essentially make them available the same way that digital media providers make video listings available today. You don't have to be downloading a new app every single time you want to experience a new VR environment.
They ought to make the day the time changes, the first day of summer.
So I think that's where we end, but there's a lot of key things in this VR experience that I'm showing you. One is just that we wanted to make the experience cross-platform. We wanted to be able to stream most of the assets, because when we think about the content of the future, it's not just about 2D video, it's about 3D models, it's about textures, it's about content with volume. We're also thinking about how we integrate traditional 2D into all these environments as well. And one of the things that's featured here, which I didn't really talk about earlier, is that this is built on a customized 3D engine that is specifically been optimized for being able to render live streaming content, which was actually one of the challenges that we also had when we started this project. So having showed you a few different types of experiences that the environment platform can deliver on, what we wish we had known before we started on this from the get-go was knowing that what we could do with GPUs for real-time video rendering, and also be able to have the CPU work for low-level encoding tasks and be able to leverage auto-scaling. And having said, showing some cool things today, what is there that still needs to be done? There's a lot. And a lot of it talks about the future of the GPU. The GPU is going to be commonly used more for delivering these types of experiences, both in a more over-the-top fashion, as well as we're probably going to have to really look at how we integrate GPU technology into core network elements, whether, if you think about delivering it on Verizon or on some other telco network. And we really have to start to figure out so that we can make these like super high resolution, even richer experiences that, as we get close to being indistinguishable from reality versus, kind of more what's shown as like a 3D gaming experience. Like, how do we solve that low latency challenge? How do we, fatten the pipe? And so that's one of the things that Verizon as a whole is looking at when we talk about the migration to 5G. When we talk about mobile today, especially on 4G LTE, you're basically looking at 40 to 200 milliseconds round trip latency when you're actually like streaming anything. And so with 5G, we're looking at how we can basically, empower the network, make it smarter, integrate more stuff into it, so that we can cache things in a better way, as well as figuring out how to bring that, with 5G delivery technology, bring that latency down to about 10 milliseconds. So if, really like the same demands if you're like a, hardcore gamer about having low latency is also necessary here. And so we're hoping that when we deliver on 5G with a high bandwidth, fixed wireless high-speed pipe, we're going to be able to not only achieve that gigabit network delivery speed, but also hit that 10 millisecond or less latency mark. And so finally, to recap, what we did with environment was deliver what I'd quote unquote call a cross-platform, cross-functional experience for both AR and VR content. We were able to then give people building tools so they can create these experiences. And today, before we cross that bridge from, quote unquote, I'd say 2D content to true VR, AR, volumetric content, we support very rich, immersive 360 video pipelines, being able to accomplish both real-time stitching and live encoding and delivery. And then ultimately, we're solving one of the major challenges of all time, which is like, how do you make advertising fun and interactive? Today, when people watch a pre-roll video before whether they're watching pre-roll on YouTube or they're watching pre-roll on Hulu, you're like, man, you may be seeing more relevant content now because the analytics are getting better, but you're still saying, why can't this advertisement be fun? And that's something that I think people can do in both VR and AR. When people want to buy something, they want to interact with it, they want to be immersed with it, they want it to be rich. And that's something that we can deliver, and we're targeted to do that both on the smartphone and the headset. And then finally, to recap, this is my contact information as well as Vinay's. And because VR and AR are such a high priority for us, we're very actively recruiting the best of the best in the industry, whether it's around video encoding, 3D computer vision or SLAM, volumetric reconstruction, lots of CUDA coding and OpenGL coding. And we have, we're basically, we have a giant hub on the East Coast as well as operations on the West Coast. So if you're interested, you can reach out to me and, we can talk and join a very cool team that's trying to accomplish a lot. And with that, thank you.